maybe, okay, let me just say to all the students first, this is my first time teaching a lecture in a while. I can go over some of my background if you guys want to meet me a little more. I used to work at Full Stack Academy as a instructor for a little over 2 years. So I have a lot of experience doing general software development, bootcamp, instructor type role stuff. But I haven't taught live in like 2-3 years or more. So please tell me if I'm like going too fast or if I'm being like too theoretical and not focusing on what you guys want to focus on. I really want this to be as much of a conversation as possible. And obviously Zainab and Adam, chime in too, and everyone who, I know we have a system of getting feedback at the end, so please do give that feedback, because especially early on, I'm going to be reading all of it to make sure that I'm actually helpful. Yeah, so first off, if you go to our curriculum repo in unsorted, we have a redux.md doc. That's the main document for following along today. And then also in the Sierra repo, or the Sierra organization, we have a demos and notes update, where demos and notes, there should be something called Redux now, which is a folder that contains a few projects like bare bones Redux, simplified React Redux, and modern React Redux. And we're going to touch all of those. I just want to say up front that Redux is something of an advanced topic. And so it's understandable if some of you have trouble following, or most of you. But the thing to note is that Redux does things in a relatively strange way, like React, but even stranger in that it follows, or it does things in a very functional programming sort of way. And you're probably not familiar with that. A lot of programmers in industry, even 4-year CS or even been working for a long time, are also not necessarily terribly familiar with functional programming. And so Redux would look weird to them too. And I think as much as possible, we want to dive into that. So please call out if something seems strange, because it is strange, and it's all strange for a reason. And a lot of it is stuff that you kind of have to understand a bunch of strange concepts all together, and then it finally starts making sense. Cool. So what are we going to do today? Our 3 main topics we're going to try and cover are: 1, we want to define the problem of state management as it applies to front-end web development. 2nd, we want to learn to use Redux to solve that problem of managing global application state for a front-end app. And then finally, we want to learn to integrate React and Redux in the modern way with these new tools, React Redux and Redux Toolkit. The last time I used Redux professionally was like over 2 years ago, and these tools didn't exist yet. So the first thing I'm going to do is build up a little by little, where I'm going to show you first. You'll never use it this way, but I'll show you Redux totally on its own, not integrated with React. And then I'll show it integrated with React in a very basic way that doesn't assume these more sophisticated libraries. And then I'll show it with these libraries, which from what I can tell, have just pulled in all these other libraries that people liked that were part of the Redux ecosystem, and they make it way easier, which is good. Like certain things just work out of the box now, whereas you had to integrate things before. But yeah, that didn't exist 2 years ago. And another thing to note up front is even the use case for Redux has changed. It's still a useful idea, but when Redux first came on the scene, we didn't have use state as a hook. So it solved just a very general problem of how do you deal with state at all in React in a decent way. And in the modern day, the nature of hooks are that you can use state and use context and use reducer to do everything Redux does, but Redux is still a choice some people make, but it's no longer like a necessary solution. It's just a choice now. So At my last job, we didn't use Redux at all. We just used the standard React hooks, and that gets the job done. I feel like I talked a bit, and we're about to get into the lesson proper. So I just want to take a sense. I mean, I feel like I'm talking a lot, and I'm not necessarily getting feedback. So how do people feel about that? Or you know, Adam or Zainab, how do we? Are we good? I just want to get a sense of like.
For what?
Just like, how are we feeling? Am I going too fast, or are we?
No, I think this is great. Yeah.
Great, awesome.
Agreed.
Awesome.
I have a thought.
Yeah.
So, I mean, I don't. This is just the initial impression, but it seems superfluous if it's not. You know, I mean, if we can use the use states in React, what's the point of using Redux?
Yeah, great. Yeah, no, I like that feedback. You're absolutely right. It's something that you'll see. We're going to get to it. There's still a use case for Redux, but what I wanted to make clear is it's not, it's sort of like there was a time where it filled a necessary role. There was no good way of dealing with state in React that was built in. And so Redux was a really common choice because React is just the view layer. It doesn't really handle stuff like state. It didn't really have a great way of doing asynchronous stuff. Since then, since React hooks became a thing, you now have these sort of built-in solutions. A lot of them learned from Redux. Redux was invented by one of the people on the core React team. So it's very compatible in that way. But yeah, basically essentially the best ideas from Redux have already been integrated into React on some level, but it's still a useful tool to know about because some companies either who started before hooks or even some after who want just a solid, consistent way of doing state that's very predictable, will choose it. And what we're going to get into pretty soon is just the very problem of state management and why a library like this might matter, even if you have used state.
And I just want to very quickly add, the term state I know is confusing. I think we're talking about the overall state of the program, not just like React component state specifically, though they overlap. And Benjamin, I wanted to ask if you'd like myself or Zainab to keep an eye on the chat and chat out questions or anything like that.
Oh yeah, absolutely. Because the nature of my screen right now is I don't have space to even see the chat if I wanted to. So I can't be on top of the chat seemingly.
Cool.
Okay. Yeah. And yeah, definitely please do ask questions and we can jump into it about like, I'm kind of using the word state, and an earlier iteration of this lecture really tried to dive in deep to what we even mean when we say that. But for the sake of time, I kind of shortened it up. But yeah, these aren't dumb questions. These are very essential questions, which like, what do we even mean when we say state? So in terms of, you know, where we're even going here, you know, it's always good to start with the basic why question or what, and that is what is Redux? And according to the official documentation, they would say Redux is a predictable state container for JavaScript apps. So what does that mean? What is, I mean, okay, JavaScript, but predictable state container. So first note, it didn't say anything about UI libraries or websites. This is a tool that you can technically use in any app where you have this problem of managing state. And what is state? State exists even in regular JavaScript programs. So if I were just to create a random file here and set it to, not that, I guess I want to, JavaScript, you guys can see this, correct? You can see my, right. So what is state? If I say const x equals 1, technically that's state. I just created a value called x and set it to 1. And because it's const, it's never going to change. So we're not going to really encounter a lot of the issues of state. And yet, if I had something like for, you know, let I equals 0, I is less than 10, I plus plus console.log I. I mean, you can't get much simpler than something like this, but this is already a case of state, and why state matters, because every iteration of this, the value of I is going to change. We're setting it initially, but I is going to have a different value each time. And note that I is overridden each time. So once this is all done, we don't have a record of anything. I mean, I disappears when the for loop is done, but on that last iteration, I is 10, and we don't have a record of I being 9. And you don't need to have that record, but it's something to note up front that the nature of state is basically, it's a context in which code executes. So console.log I isn't meaningful without an I. And when the program hits this, it's going to say, okay, where's I? Let me look in the closest scope I have. And the closest scope is here. And it's going to know the current value of I. So it's going to use it in that context. And then the next time it's run, I is a different value. And that same exact line of code now does something different. And these might seem like, obvious, like, well, that's just how programming works. But the entire field of functional programming is basically about what problems you run into when you have, when your code depends on context, and when that context can change invisibly. There's no record of the change. And all the breakthroughs of functional programming are generally about avoiding something that a programming language gives you normally. And the reason you're doing that is because you want to maintain this predictability, or sort of this like tracking of your state, because you don't get that normally. So yeah, when I say state, think of it like context. The fact that when you run one line of code, it can do something different each time. That is state.
So I have a question.
Yes.
If you put something into a shopping cart and the inventory is highly transactional or volatile, does this help solve that trouble where if I put something in the cart that might eventually be sold, if 1,000 are being sold an hour and there's only 500 remaining, that means I only have a short number of minutes to execute the cart. Does this help address this issue?
Well, what you're referring to right now is a question of, generally that's going to be something where you might put it on your cart on the front end, and then before anything can happen, the back end is going to have to confirm, yes, it's really there. And that boils down to this general question of single source of truth, which Redux will take on. But in terms of the general problem of like databases and what was the term you used? Not volatility, but
Transactional.
Yeah, exactly. The fact that a database can take time to update, I think that's the phrase we're looking for here, whatever it is. The fact that a database is not consistent immediately, this does not address. What this does address is the idea that you're going to have a sort of complete record of all the steps you've taken, and whatever system you have by which you're keeping track of the inventory, you'll be guaranteed, you'll absolutely know that you sold something, and then you tried to sell something and it was 0. And you have this you're not going to run into sort of conflicts of two things running at the same time. It's not exactly what it's meant to address, but essentially, as we'll see, you have this very solid record that lets you easily rewind time to see where you were a few seconds ago, or if you run into a bug, you know exactly the set of steps to recreate it because it's all documented, essentially. Is that satisfying?
Sure, thank you.
All right, fair enough. Yeah, so let's get into the general problem of state as it applies to front end, or not problem, because it's not necessarily a problem, it's a feature. You want to have state. Importantly, you should know, if anyone ever says like, oh, Haskell or OCaml is a pure functional programming language, there's no such thing as a pure functional programming language, because that would mean it changes nothing. As in, you run the program, nothing happens, because without state, you don't have a console to print to. There's no screen that changes in response. State is useful. So right here, I just, threw together a small little example of a modal. So let's say you have a website and, you're just going to ask some question, who knows why it is, maybe they're changing the theme or something. And you want a little pop-up to show up that says, did you mean to do this? Yes or no? So a way you might do this, I'm assuming there's some, just jump back to it. I'm assuming that there's some component called modal that I have access to. But the idea is that I'm going to keep track of this modal open state using useState, which we've already covered. Set it to false initially, and then here in the in our body, or I'm almost forgetting what we want to call this, but in what we actually return from our component, the HTML, we're going to check first. Okay, well, is the modal open? And we in standard React style we use a ternary operator, which we're all familiar with that, right? So if the modal is open, we show the modal. If the modal is not open, then we show the button that lets us open it. We can respond to that button by changing the state, and that refreshes the React component. And similarly, if we record an answer, we're going to record it in state, and then we'll set that modal open to false, and that will again update the app as expected. So state is a concept we already have, and on some level that should be good enough. And you can get very far just using useState. But there are problems with useState as a program grows, and that's a little hard to show with an example that can fit on the screen so easily. But looking at this picture here, we're going to try and imagine, like, this one has a parent and 2 children, and this one has a parent and a few levels. But you just want to imagine what a website like Facebook or GitHub or some other React app might look like in terms of its component hierarchy. It could be 1,000 levels deep. It could have 1,000,000 components total. So this problem I'm going to explain really gets bad as you scale up. And as I see it, there's essentially 3 problems that you encounter using useState and a naive state management solution. So the 3 problems you generally have in state is, 1, the data has to live somewhere, and if you want everyone to theoretically have access, technically the data should live at the root. So just like a CEO might, think about it this way, like it's a terrible design for an actual company, but imagine you have a CEO, and if any data wants to be, dispersed to the company, no matter where that data comes from, it has to go to the CEO, and he has to tell his direct charges, who tell their direct charges, who tell their direct charges. And that's how, updating something like useState works by default. So first, passing data down the hierarchy. As you see here, at one level, it's pretty easy. The data lives here. You have some children, you'll pass it down as props. But as the hierarchy grows larger, you have this problem that we call prop drilling in React, which is, let's say you had the theme for a website. Every component is going to, more or less, is going to want to care about that theme. And if you stored it at the top level, you'd have theme equals, some object, and then you'd pass it as a prop to its child, or all of its children, and all of their children, they would have to pass it as a prop, and on and on and on until the bottom level. And the problem with that is that not only does a component have props that are relevant to itself, it has to have all the props that are relevant to all of its children. And you just end up writing a lot of boilerplate, and it makes your app harder to read, and it's sort of unnecessary because it's just by design of how props work that you have to pass it down and down and down and down. And if you're familiar with it, you might be saying like, oh, well, use context as the solution here, and it is. But there was a time where that didn't exist and Redux was the solution, and modern Redux simply uses use context under the hood so that if I have a piece of data that lives up here and I want to pass it down here, I don't have to pass it down all these levels. This component all the way down here can just, I don't know if you know what I'm pointing to actually, because I don't think you can see my mouse, or maybe you can, but oh, you can, okay. But anyways, the green, bottom component that cares about the data, using something like Redux can just say, hey, I care about that data, so inform me. You don't have to inform everyone along the hierarchy. Yeah, so in bold, Redux addresses this issue by allowing us to pass state directly to the component that cares about it. So the second issue is informing others. So let's say down here at that green place, you actually had, your component allowed you to change the theme. And theme might not be a great example here because every component will generally care about the theme, but let's say it's something where this component let you update your email address. And you want to tell others, but it turns out only about 5 of 5,000 or 50,000, 500,000 of your components care about what your email currently is. So with something like use state by default, not only would you have to pass that function that allowed you to update the email all the way down, but once it was triggered, the change would happen here at the root. And then it would say, okay, well, I'll tell everyone, let's rerun your every component just in case they depend on this data. And it would be much better if there was a way of saying, okay, just the components who care can register their care and say, I care about that, so no one else has to re-render, and I only re-render when things I depend on change. So that's another thing that Redux is going to allow us to do. And those first two issues, actually, we're not going to get to them until relatively near the end. But that's because that's sort of what the library React-Redux does for you. It integrates the two very well. But Redux at its core doesn't know anything about a component hierarchy. So what is Redux even for if it's a pure state management tool? Well, the third problem, which I think is the most important problem by far, is if you've been programming, you've probably encountered situations where you have bugs. And what you probably notice when you hit those bugs is you took a set of steps that led to that bug. And so if you refresh, you might not get that bug right away. Rather, it was someone was using the app, they did, 10 things, maybe 10 things you didn't particularly test for. And then after doing those 10 things, they're in a state such that the next action they take causes some issue that you didn't expect. And the reason why these bugs are often hard to debug is because you need steps to reproduce. So if you're a programmer and a QA says we have this bug, the QA is going to maybe have a little video using something like Loom, and they're going to say, this is the bug. And as the programmer, you're going to say, okay, steps to reproduce, as in how did they get there? Because I'm not seeing that problem. And that issue of I'm not seeing that problem, but someone's seeing that problem is difficult in part because you have no record of what steps they took. And Redux is specifically designed for this solution. So when we get further into it, we'll see the Redux dev tool. And the real selling point for Redux is what they call a time travel debugger. Not really time travel, but essentially, let's just see a quick example because we can do this. So I'm going to go to Airbnb. Airbnb uses React, as it turns out. And as you see here, I have my Redux dev tool, and already it knows that a bunch of things happen. So I can't see them too well because, okay, let me, all right, yeah. So Airbnb /save to list modal / set mutations. So some things are happening, and here I can see the entire state that Airbnb cares about for this website. And importantly, if I click on this, even just hovering over it, a bunch of actions happen. And then I'm going to click on it. That I guess brings me to a new page. But importantly, like things things happen. I'm going to set a random date. That's when I'm going. And we're keeping this like constant. I'm surprised that that doesn't have certain information. I want to see something change, but essentially, it knows when things change, and it is able to keep this data such that, I mean, it's a little hard for us to see visually right now because I didn't quite plan this out, but basically you can rewind to the very first step of the app loading before any actions took place, and then one action takes place and another and another and another. And your app is just very predictable in that you have this tight coupling to an action with a name, with data, and what that resulted in, and everything is step by step. So I don't want to get too ahead of myself because we haven't really discussed these ideas deeply yet, but that Redux dev tool is a big use case, or it's a good selling point. And even here, like we can see I have this basic counter app we're going to get into. So let me reload it so that it's fresh. So we have this. Oh, right. Sorry. You know what? We're gonna talk through it a little bit at a time, and we're gonna get there when we get there. So let me just reopen. There we go. Cool. So we're gonna talk about. We've discussed the use case for Redux. I just want to stop there for a minute because that's a topic. So how do we feel about the use case for Redux? Like, do we feel like there's a legitimate reason why we care about state management?
Maybe mostly, like you said, for debugging very obscure bugs that you wouldn't be able to otherwise.
Yeah. I mean, that's definitely good enough for me. The first two ideas we're going to get into eventually, but those are mostly efficiency issues. The third idea is essential, which is, I mean, think about like a video game. Everything that happens changes the world, and so much can happen that, you know, that's why video games are full of bugs. That's why operating systems are full of bugs. You eventually hit points where you're like, how the hell did we get here? We're at step 9,999 if you never turn off your computer. And this is a way of tracking all of that. So just like an interesting use case for functional programming. Does anyone remember the game Braid? Is that what it was called, Braid? Anyone here an indie game person? Basically, it used the mechanic of time travel, and the programmer had to discover this idea in functional programming in order to make time travel in a game even possible, because you had to know what the previous actions were, and you had to have some way of either recording it or being able to compute the previous action based on the current action. And this whole idea of like tracking your changes in state is, it ends up being complicated, and systems like this end up simplifying it. So yeah, anyways, we're going to start with this thing, this little project that you should see in demos and notes called Bare Bones Redux. And in it, I build up step by step the essential components of Redux. And I just want to warn you ahead of time, it's going to be a little weird because these ideas don't make sense on their own. They only make sense when they all come together, but we will get there. But, you know, feel free to ask questions along the way. But first, in terms of like the high level overview, this image here is helpful. This is what we call one-way data flow. So to understand why one-way data flow is useful, it's a little hard in the modern day because things like React 1, and they're all about one-way data flow. But something like Angular, in Angular, you had, you know, a data model, and then you had, a view model, and then you had your view. Your view is like your HTML, and your view model was the data backing it. So in that way of doing things, let's say you had like an input box, you could type a value into the input box, and that would change. So that's coming from the view, and that would update the view model. But in the same way, you could just, you know, at the view model level, say, okay, well, I want to change that value, that, you know, instead of whatever the input is, I want to change it to, you know, Ben, and then it would update, you know, from the view model, it would update in the view. And that's what we call two-way data flow, where they're connected such that you can update it in either way. And that is a good approach if you want things to mirror each other. The downside is that when a change happens, you're not sure who triggered it, and that can get very confusing over time. So this idea of one-way data flow came up, and one-way data flow is a good example of this general programming idea called indirection. So there's an idea in programming which is basically almost every problem can be solved by adding a layer of indirection. So I want you to imagine we're going to take this actions thing out, and we just have a line directly to state from view. So in that case, we have two-way data flow. The state can update the view, and the view can update the state. And because they can update each other, we don't have predictability because if a change happens, who triggered the change? Redux is going to use one-way data flow, and the way that works is through something called actions, which are our level of indirection, where the state is our single source of truth. It's a phrase we're going to use a lot, but this is where data lives at the data level. This is where an object lives. And then much like in React, we're going to start with our data. Like, if we were using use state, we have our data here. And then our view just reacts to the data. Our view reads the data, but it cannot directly update the data. What the view can do is trigger an action. And that action can in turn update the state. You might wonder why this is a useful approach. Because what are we gaining through this indirection? The basic idea is that this actions part is where all of the recording of things are happening and where the controlling of changing things are going to happen. So basically, the view always reacts to the state, but the view cannot just change the state. The view has to send an action, and that action has to be very defined. And as a result, that's going to, change how things work. And a good example of this, just to, create something quickly, you may have seen this in object-oriented programming, but this is a general idea where we have this idea of like getters and setters. So if I had a piece of data like const x equals 1, or better yet, I'm going to have something like these are bad names, obviously, but I'm going to have some object, and it's going to hold something called x, and I can print out console.log object.x. And then if I was doing things this way, if I wanted to change it, I would have to say something like, or I could say something like object.x equals 44. And that would just change it, but it's changing it in such a way that whoever has access to object can just change x at will. But another way you might do it, which a little harder to demonstrate in JavaScript because we don't have the idea of private. But basically we can have, let's say we had an object and we're going to use like exporting, right? So we have our object here. We're not going to export our whole object. We're not going to export, well, we can, right, we're not going to export X because we don't want them to have direct access, but instead we can say something like get X, which is a function, and that function is simply going to return object.x, and then we're going to have const set X, which takes a value, new X, and it does something like object.x equals new X. And then we're going to export sorry, the modern, I guess we say export. I mean, we could always use, module.exports, but this is the basic idea, where the idea is any other file that had access to this file only has access to get X and set X. You might say, well, there's no difference here. Getting is always just getting. And in this case, setting, well, you're just writing something over set. But I could easily put a check in here where I can say, if new X is less than 0, just return. And only if that's not true do we continue. And in doing this, I just created a level of indirection by which you can't, like, basically I have a level of control over what happens in X now. And just as well, I can say, okay, well, before that happens, I want to, write to some file, okay, we're changing X to new X. And suddenly we have like a logger. So this is the core idea of why we're even doing this in the first place, this idea of actions. So I just want to stop there for a second. How do we feel about this general idea of indirection? Like, is it useful? Do you see the use case of why directly accessing and setting a variable might be less, I mean, it's certainly more convenient, but it might be less predictable than a system in which we only gave people access to a getter or a setter function?
Essentially, we can control what they're allowed to do with whatever variables, and it gives us a little bit more protection from Bobby tables, and everyone else will know what that means.
I don't know what that means, but you're absolutely right. That's it. Control. The word predictability is basically about control, as in, if you have a home and your home, or this is now an insane idea, but if you have a home and the home has no walls, anyone can come into your home from any direction. But if you build walls and there's a door and there's a lock on the door and you have a little peephole where you can see who's coming and going, suddenly your home has a level of predictability it didn't have before. You might not be able to choose who shows up at the door, but you have a lot more control of saying, I'm going to open the door when I want to, and I'm going to first check who's at the door because that is a significant factor. Yeah. So now let's take this idea of state, view, actions, one-way data flow, and we're going to look at a more Reduxy approach to it. So this is Redux's same thing here, where the state you could see as replaced by this store, the view is the UI, and the actions is this thing called dispatch. And we could just watch this for a little while. This is what Redux is. We're going to get into what all these ideas are. But this is how Redux works, as in, here I have my store, which you can see is this, general thing, which at the heart of it seems to be this thing called a reducer. And this store is all about managing this thing called state. And our state in this case is a number. It's going to be, 0. And the first thing that happens is we send our state to the UI, and the UI can then render it. But given that it's a UI, we're going to be able to have like click events, and those click events are going to be, event handler here just means just like in a web browser, you have an event handler system. So we're going to respond to those events with this idea called dispatch. And we're taking that click event and we're turning it into an action, which, as you can see, is basically just an object. And then that action, when it reaches the store, is going to update the state so that on the next run through, the state equals what you want it to equal. And then importantly, we have this idea called a reducer, and you'll notice there's multiple little R's here. So the reducer is the heart of the store. The store is sort of the container that allows or prevents access. It's that level of indirection. And the reducer is going to be the logic that allows you to determine how to respond to an update. And the little R's are for the fact that even though you have one, what we would call root reducer, your reducer can be split up so that, if you have a lot of state, it can, be handled by different things. So again, if I were to go to airbnb.com, I like that I can do a real example. I'm going to go to their little Redux thing here. If I look at their state, there's a lot here, and I don't know that I can make this bigger, but I mean, there's currency, there's footer. I mean, some of these things have a lot more inside of them, and I'm sure they can get very nested. And as a rule of thumb, basically every high level piece of data that your state represents is going to have its own reducer, because that's basically a unique, bit of logic that is going to be concerned mostly with itself. And obviously there's the root reducer if you ever need, one area to know about another. But yeah, not to get ahead of ourselves, let's continue with this. So just to go through these ideas at a high level, once again, we have the store, and the store contains the state. It's the level of indirection. Like the state is like what the store sells, more or less. You got to walk in the door. You got to play by the rules if you want to walk out with the state you want, or otherwise, make a transaction. The UI is going to be your layer by which you display the data. So it's going to grab the state, and it's where you're going to dispatch actions. So you can't update the state directly, but you can dispatch actions, which will eventually update the state. Keeps jumping. So yeah, actions are, as you see, just objects, but actions are how we represent how we want to update the state. And then the heart of this is going to be the reducers, which are how we respond to a dispatched action in order to update the state and keep that circuit flowing. So we're going to get into a very basic example in a second. This thing called in demos and notes, I have this thing called bare bones Redux, and that is an extremely basic app. We're not even using React. As you see, I have one dependency, which is the modern way you grab Redux. This is technically Redux toolkit, but that is basically the Redux core plus a bunch of other useful things. And we're just using the core, but this is the modern way to do it. So just this one dependency, just a basic node app, but we're going to show each one of these ideas built up little by little. But before we start, how are we feeling about this general explanation of what Redux is?
On the moving diagram,
Yeah.
can you explain why, as the event handler is passing the information back to the store, the state is kicking out a 0 value going into the reducer at the same time?
Yeah, so we're definitely going to get into more detail about that, but that is very important. The nature of a reducer, as we will see, is a reducer takes the existing state and it takes the action and it combines those to create the new state. So the existing state is a input to the reducer along with the action that creates the new state. You only generally by default have access to the current state. So you can't say, well, whatever it was 5 states ago. But this is an important point, as we will see, and it's why it's called reducer, and we'll get into it. But yeah, that's a great question, as in, why should it even matter? Because theoretically you could just say, just update the amount outright. But in this case of like a bank situation, you might say, okay, my deposit is 10. Well, that's not enough, as in what's your current amount? Because that's how we arrive at your new amount. Yeah, but yeah, great question. But okay, let's dive into it now. And we're going to end up spending a bunch of time with this idea of reduce.
Oh,
So I just want to get, yeah.
I just wanted to pretty much make sure too that I was understanding the one-way data flow. But so basically the state stores the initial data and then sends that data to the view to be displayed. And the view is giving you pretty much choices that are sent to the action or the event handler, and based on the action, the data is sent back to the state, which is then set with the new data and updated by the reducer. Is that correct?
Yeah, no, absolutely. You have that, and that's even more specific, as in that's essentially how Redux thinks about it. But at this level, it's simply that the view cannot directly update the state. Okay. Because imagine you didn't have any of this; you just had state and UI. If you had those directly connected, then you have this question of who's responsible for the update, and you can easily run into weird situations where, you know, if the UI allows it, you can just change the state outright. If the single source of truth, that is the state, allows it, a programmer can just write, okay, now it equals something else, and there's a lot less tracking going on. But yeah, no, you generally have the core idea. Okay, so you guys can see my screen here, right? You can see this 1-store business. Okay, I'm gonna minimize my my seeing of you guys. No, I'll actually just move it over because I want to continue to see people. But yeah, so we're gonna build this up little by little. So as you see here, 1-store is about as basic as it gets. First, we're importing from Redux, and normally I would say like import, you know, the sort of partial import, we do something like this, but it turns out if you're doing things purely in Node, while you can use import syntax, it doesn't like that. So this is just me grabbing one thing I care about off of Redux. And then we're going to configure a store. So that's that store that, you know, we saw up here. And the store doesn't mean anything without a reducer. So by default, I'm just going to give it a function that does nothing. And I'm going to save that as store, and then we're going to print out the store. So this is you know, absolutely bare bones. It does not do anything yet, but it's worth seeing. And here's the reason why I do want you to see it. All right, let me. Okay, so what is a store? Like most things in JavaScript, it's just an object. But we're going to zoom in on, you know, there's a little bit more happening here. I actually don't even understand fully what is uniquely good about this add observable, but I know it's a thing. But just these three functions up here: dispatch, subscribe, and get state. So I wanted you to see this just because this is the core API of a store in Redux. And when we get further on, especially in like the modern part of things, we're not going to use those in a direct way anymore, because there's going to be like a, you know, a more abstracted, more React oriented way of doing it. But it's worth understanding this is the core thing, is in everything that happens in a Redux store happens through dispatch, subscribe, or get state. And additionally, like configure store, because that's how you create the store. Cool. So now we're going to get to this idea of a basic reducer. But before we do that, let's do a little review of this idea of reduce. So I just want to get like a show of hands, or not show of hands, but how familiar are we with this dot reduce? Like, have we touched map, filter, and reduce?
I remember using it a little bit in coding challenges, primarily like for like basic arithmetic.
Mm-hmm. Okay, yeah. So we're basically familiar with it, but reduce is an interesting one. It definitely comes off strange the first time you see it. Even some of the names of these variables I use might seem strange. And I wanted to walk through how reduce works, you know, with an array, so we can understand the more general concept. Because while Redux uses the name and idea reduce, it's not just for arrays, but arrays are a really good intro to it. And I just want to reiterate, reduce is odd. It's an odd idea. But yeah, so let's look a little more deeply into it. So when we even say reduce, what do we mean? In some other languages, this is sometimes called fold. And I like that name better because it's a little more obvious what it's doing with an array. You're kind of folding the array up one value at a time. But reduce, its role is that it takes a piece of data, like an array, and it reduces it to a single value. So one way of doing that would be you take an array like 1, 2, 3, and you reduce it down to its sum, a value like 6. So first there's this thing going on where we're going from one shape of data to another. We're going from a higher dimensional thing, an array, to a lower dimensional thing, a value. And how do we do that? Well, first we have our second argument, which represents the original state. The second argument is just going to say, before you do anything, start with a 0. And why before you do anything? Well, because the first argument is what we call the reducer. And I use these arguments here because this is what I like to call them. You might have seen people just write X and Y as if you're adding each number together, but I don't really love that way of thinking about it. What's happening in reality is that the first value is an accumulator. It's what is being built up and being, it's the first input to the function, and then also whatever you return from the function updates the accumulator for the next round of the function. And then current is whatever the current value you are on in that walkthrough. So if we run something like this, it would look like, our accumulator is 0, and then we look at 1, and then we add accumulator of 0 plus the current 1, that equals 1. So now accumulator is going to equal 1, and we run it again. And now accumulator is 1, current is 2, because we now moved on in the array. That equals 3, accumulator is 3, on until we're done with the accumulator, or sorry, we're done with the list entirely, and then we return the accumulator outright. So this is a really core concept that we want to dig in on if there's any confusion, because it's not necessarily obvious. And I mean, I have two ideas. One is I guess I essentially have one idea, which is we can re-implement reduce for an array very quickly right now, and you can kind of see how it functions. And it functions just like, solving basic problems where you have like a local variable. But do we think that would be useful, or are we all pretty good on what reduce is? Like, I'm going to make a function right now, or I'll say const. We're just going to call it reduce, and that function is going to take as an input, instead of being a method on an object, or a class rather, we're going to say something like it takes an array, it takes a reducer function, and it takes a default value. So how do you guys feel about this? Should we implement this? All right, yeah, let's do it. So should I just do it myself, or does anyone want to try their hand at this? Because it's ultimately not that complicated. You've done things like this, just, if you've relied on reduce, you think of it as like using this higher level function. And instead, now that we're inside the body of reduce, we want to actually do all that bookkeeping ourselves. So can anyone, like, for example, what might be the first thing I would do? Before I can do anything with reduce, I have this default value. What might I want to do with my default value?
Set it to 0.
Well, my default value, maybe it is already set to 0. So if I recreate this, it's going to look something like reduce 1, 2, 3. And then that was accumulator current, and then 0. So basically, I have this value 0 being passed in, but it's not like, how do we make it useful to us internally in the program?
Would you set that as the accumulator?
Yeah, exactly. So I might have a local variable, which I'm not going to make a const, but a let, because it's going to update. I'm going to call it accumulator, and I'm going to set it to the default value. Cool. And then we want to return something from here. What are we going to return when we're done?
Would that be the
accumulator.
reducer itself?
What? Can you just repeat that?
Go ahead, Eric.
I said return the accumulator.
Yeah, exactly. And then in between, we obviously want to walk through for what's my let logic again, or I'm going to do for val of. Am I getting my JavaScript correct? I sometimes forget if it's of in. So for let value of array, what do we want to do at each pass?
Accumulator plus value.
Yeah, we could do accumulator plus value, but this is a general purpose version of reduce. So we have this function we're passing in, which does that, called reducer. So how do we want to utilize this function?
Just reducer then.
Yeah, reducer applied to our current accumulator value and our val, which, you know, for simplicity's sake, or whatever we'll call it, cur. And then we have one step left. What's missing right now? As in, we're running like reducer 0, 1, and it's returning a 1, but then we're just throwing it away.
Let it equal to accumulator?
Yeah, so this is it right here. This is all a reducer is really doing. It's yeah, and this should work, as in I haven't even tested this, but again, and it wants an actual place for me to put it. I'm just gonna, I don't want to waste too much time with this, but why can't I just save it right here? Did I save it? Yeah, I gave it a terrible name. Okay. I just called it, you know, reducer.js, and now let's try and run it. Node reducer.js. Right, I didn't print anything. That's an important point. You always want to see your result. I'm going to set my result here to value, and if this prints 6, I'll be pretty happy. And it prints 6, great. So yeah, that's the core concept of a reducer. But it's going to build up in a couple levels until we get to the way Redux thinks about it. So first, we want to recognize, and this is a bit of a trippy step, you can, like right here, our reducer is taking an array and then one at a time updating a number, right? Or just a variable that holds a number. But what if we did something else? Like essentially, what if we try to do what we do in map, but instead we're doing it in reduce? So essentially, let's say I started with something like, I'm gonna, you know, create a second thing here called result2, and we'll print that out. Let's say I'm starting with 1, 2, 3, and I want to double the value of 1, 2, 3. The answer is technically in there, so you can look at it, but can you see this as in how might we do that? How might we take in a array 1, 2, 3 and return an array 2, 4, 6 just by updating these two arguments? Let's start with the accumulator default value. If we want to return an array with 2, 4, 6, what might our starting thing be?
2.
What was that?
Be 2.
Well, I mean, if it was 2, then the first time we ran this, whatever this is, the first thing the accumulator has access to is 2. And that's actually before our thing even runs. And we have no idea what this input is going to be. It could be 2 itself, and we want to double that, and that's 4. So what's a good starting value if we want to end with an array containing things? Like the first thing we want that's going to be passed in along with our first value. I'll just give it to you, I guess. Empty array. Why might we want this? Well, the first time this is run, we're going to set, like, just think of it this way, like what might make sense if you had to build up, like, you know, you're passed in an array and then you want to build up a different array, right? So what's a good first value for this, you know, bookkeeping variable you have? An empty array. And then what might you want to do at each step? As in, you're given an empty array and 1. How might you want to transform that? Like, what is the function that's going to take an empty array and 1 and return the next iteration of what our current solution looks like that will be passed to the next iteration? If this seems strange, to be fair, it is, because this is not how you're used to using an array. You're used to mutating an array in such a way that you would say, you know, given some array, I'm going to say act.push. But that's not going to quite work here, as in we want to start with a default value and a current value and combine them to get an intermediary solution. Does anyone have ideas on this, or should I just, I mean, it's technically in the curriculum, but the solution, yeah.
So basically just multiply the current by 2.
Yeah, but here's the thing, if I do the current by 2, then what is the next, like basically I'm starting with an empty array, and then the next time this runs, or the next iteration of this for loop, what will accumulator equal at that point? It'll equal 2, right?
Yes, because we're starting with 1, so 1 times 2.
Yeah, but the thing is, we started with, so basically, if we're following what our accumulator logic looks like, if we follow our accumulator logic, we start with an accumulator that equals an array, and then we're going to combine an array and the value 1. We're going to, you know, call reducer on empty array and 1, and that's going to result in a 2. And then the next time this is run, it's going to look like reducer 2, 2. Does that seem right? I guess I'll tell you, it's not right. And this is a reason why something like TypeScript is ultimately useful, in that it's always kind of a sign that something might be off if you're starting with a shape of data that looks one way, and then on the next iteration it looks completely different. So why did we even start with an array? It's because we want our final answer to be an array. So we actually don't want to combine empty array and 1 and equal 2. We want it to equal array 2. And then the next time we run this, array 2 plus 2, we want to equal array 2, 4, right? We want to take the existing array, we want to take the new number, double it, and then add it to the existing array. Though importantly, we're not mutating it in place, we're creating a brand new array. So this is, I'll admit, this is odd. And this is the main reason why functional programming looks weird to people, that this is an odd way of doing things, but it's worth noting that this is how reduce has to work. You can't change it in place because it won't be a good input. I mean, it's worth testing if that works, but I don't think it will work. As in, if I run this right now, I'm going to get the result that I expect, as long as I call it reducer and result 2, and I, oh yeah, I did current 2. That's not what I want.
Or is that where the spread operator and putting the accumulator?
Exactly. Yes, we're going to spread whatever we currently have, and then at that end here, we multiply current by 2. We have 2, 4, 6. And that is good, but let's just imagine, what if we try to, it's worth seeing whether this stuff works or not, because, you know, this is the way I've been taught to do it. But basically, what if we wanted to return, we're going to return the accumulator, but instead we're going to do it in such a way that we say, okay, taking the accumulator, I'm going to push onto the accumulator current times 2. Something tells me this is actually going to work. But yeah, so it does work. But there are reasons you don't want to do this in general, just because there's a level of context that you're adding to it. I mean, it's a little hard to explain why you generally don't do it this way, why you want to actively have a brand new array. But this will come up in Redux, and the main reason is because part of how your reducer or part of how your store knows to tell people there's an update is that instead of looking, okay, well, did anything in the state object change? If the state object's big enough, that's going to take a long time. So instead of doing a deep compare, it does what's called a shallow compare. It just says, is this the same object as before? If it is, nothing changed. As in by same object, I mean just the memory address. As in, I don't know exactly how you access that from an array, but every array in JavaScript knows, okay, I live somewhere. I have an ID basically that says who I am. And even some other array that has the exact same data in it, even though deeply they are the same, shallowly they are not because they aren't the same object. They just contain identical data, if that makes sense. And so Redux will use that. Yeah.
But I think it might be a good time to throw in a small break.
Oh, yeah. Sorry about that. I didn't realize we do breaks. Very good idea. Let's do a small break. What, 10 minutes or?
How much more of the lesson do you think we have?
We have until what is 11 a.m. for me. So that's 40 minutes. And I think it's a good thing that we're like doing it slowly because we really want to, you really do want to build up here because the later stuff won't make sense otherwise.
Right.
But yeah, we have technically, I mean, this is something I only created this lecture in the last 2 days, but this is something that Adam and Zainab already know that this might not be a reasonable one-day lecture.
Gotcha. Okay. And then a 5-minute break should be fine.
All right, 5 minutes. Let's all meet back in 5 minutes. I'll eat this.